The fundamental principle behind occupational health and safety management is the recognition, evaluation and control of hazards, or as it is often expressed, the identification, assessment and control of hazards. Virtually every safety initiative has hazard control as its ultimate aim. A job safety analysis, which is also referred to as a job hazard analysis, is a safety tool. It helps people logically examine a particular job or task so that all the hazards associated with that job can be identified and assessed, and when necessary, suitable control measures can be determined. The aim of a job safety analysis, or JSA, is simply to document how a particular job should be done safely. A job safety analysis is a three-part process and is written up on a form with a layout like this. At the top of the form are basic details which include such things as the job to be analysed, the date, the location of the job, the people responsible for preparing the JSA, and so on. The main part of the form is broken into 3 columns, each column representing one step in the process. The first column is used to list down the basic job steps required to perform the task. The second column is used for listing down any and all hazards that are present. Its relationship to the first column requires that all hazards for each step are listed in line with each job step. The last column is used to record any hazard control measures that should be used when performing each step and/or any safe work practices that should be adopted. Again, these hazard controls are listed in line with each job step and each identified hazard. A job safety analysis can be developed in a number of different ways. Generally, the best and by far the most common way is by observation. Having 2 or more people actually observing a job being performed is the ideal way. The observation method has the advantage of not relying on memory, and the process also prompts the recognition of hazards. A variation of this method is to videotape the job task. The tape can then be replayed and dissected by those responsible for developing the JSA. Some situations, such as infrequently performed tasks or new jobs, result in the observation method not being practical or possible. In these situations, it is often best to have an experienced group of people complete the analysis through discussion. Let's now look at each of the 3 parts to this process in a little more detail. The first step in performing the JSA is to break the job down into its basic job steps. This step is obviously crucial, as too many steps make the analysis too complicated, and too few lead to hazards not being identified. The key to developing this part of the JSA properly is to concentrate your deliberations on what is being done and not to get confused with how it is done. Once the job steps have been decided, the second stage is to look at each step in turn and identify any and all the hazards that are present for each job step. The success of the JSA pretty much relies on this second stage and the ability to identify all the hazards that are present. Many hazards are relatively easy to identify. For example, are there manual handling requirements such as lifting, carrying, pushing, pulling? Is excessive force required? Is there adequate illumination? Does the task include the potential of a fall occurring, either from height or at working level? Are hazardous materials involved? Are there unguarded moving parts? And so on. The so-called hidden hazards can be a little more difficult to identify, and depending on the task, it may be necessary to consider such things as the presence of energy sources, including electrical, mechanical, thermal and pressure, whether or not there are hazardous airborne contaminants present, whether there is the potential of a fire or explosion, and so on. Again, it is important that the hazards associated with each step are considered in turn. Once this part of the process is complete, then the third stage requires that each of the identified hazards is assessed and appropriate control measures are then listed down. It must be decided with each hazard whether or not the risk it presents for an accident or injury either needs to be controlled or it can be regarded as an acceptable risk and does not require any specific control measures. With all the hazards that require control, the best approach is to apply the principles behind what is commonly referred to as the hierarchy of control measures. The hierarchy of control measures categorizes hazard control measures under the following headings: elimination, substitution, engineering controls, administrative controls, and the wearing of personal protective equipment. This list prioritizes control measures and acts as a guide by working down the list when deciding on appropriate control measures. The questions that it leads to include: can we eliminate the hazard altogether? Can we substitute the hazard for a less dangerous one? Can we engineer out the problem, or can we reduce the risk with a physical modification? Can we reduce the hazard by introducing an administrative control? Or do we need to consider the wearing of personal protective equipment? It is also important to remember that many hazards require more than one control measure to reduce the risk to an acceptable level. So, that is a brief rundown of the basic process. But how does it work in practice? Let's look at an example that we can all relate to: changing a flat tyre. The first step is to observe the task and decide on the appropriate job steps required. Remember, we are concentrating on what is being done, not how it is done. The first step is to park the car and turn off the engine. The next step is to get all the equipment ready. The third step is to remove the hubcap and loosen the wheel nuts. The fourth step is to jack up the car. The fifth step is to remove the wheel nuts and take off the wheel. The sixth step is to put the spare wheel on and replace the wheel nuts. The next step, step 7, is to lower the car, remove the jack, tension the wheel nuts and replace the hubcap. And finally, step 8 is to pack away all of the equipment. Now we can look at each step and decide what hazards exist. In practice, we can either proceed by listing down all the hazards that apply to each step in turn, or, as we will do in this example, we can identify the hazards for each step and make our decisions on the appropriate control measures at the same time. With step 1, there are 3 hazards. The car may be close to other traffic. The car may be on soft or uneven ground. Or the car may roll. The appropriate control measures are to park the car in a safe area away from other traffic and consider the use of the vehicle's emergency hazard lights. The vehicle should also be parked on a firm, flat surface. You should also apply the parking brake and leave the transmission in gear or park. And finally, place wheel chocks both in front of and behind the wheel diagonally opposite the flat tyre. With step 2, we have the potential of general manual handling injuries, and more specifically, a possibility of a back injury when lifting the spare tyre. The control measure here is to use correct manual handling techniques, and more specifically, to stand the spare wheel upright and position it as close to your body as possible before lifting it out of the boot. Step 3 can lead to general injuries and muscle strain. Control measures here include using even force and replacing a single-handled wheel spanner with a four-handled spanner, which is easier to use and less likely to slip. Step 4 could lead to the car moving or falling off the jack. The appropriate control measures are to follow the manufacturer's advice on how to properly use the jack and to avoid bumping or leaning on the vehicle. Step 5 presents a possibility of muscle strain or back injury, and the appropriate control measure is to use correct manual handling techniques. Step 6 can again lead to muscle or back strain, so once again, the control is to utilize appropriate manual handling techniques. Step 7 could lead to hand injuries or strains. Again, use correct manual handling techniques and apply even force when tightening the wheel nuts. And finally, the last step has the potential for manual handling injuries and requires the use of correct manual handling techniques as the logical control measure. In practical terms, the best way to compile the information is to develop separate lists and, as a final step, transfer this information to the JSA form. The end result will look something like this. And remember, the object of the JSA is to document how the job should be done safely, and this is not necessarily the way the job is currently performed. There are a number of different benefits that result from the process of conducting JSAs in the workplace. Generally, they focus people's attention on the safety aspects of performing different tasks, and therefore result in an effective raising of the overall level of general safety awareness. JSAs can also lead to the identification of hazards that have previously not been identified, or alternatively, have not been properly controlled. They are also very useful for two other reasons. One, they can be used as a guide for training purposes. And two, they are extremely useful as a reference tool when conducting accident investigations. However, the most benefit from conducting JSAs in the workplace is achieved when they are used as the basis for developing written safe work procedures. A JSA can be rightly regarded as the analysis phase of preparing a safe work procedure for many job tasks. A safe work procedure takes all of the must-know information from the JSA and presents it in an easy-to-read, narrative-type format. The JSA is one of many tools that can be used in the workplace to improve overall safety. Any process that aims to identify and control hazards will ultimately lead to a safer working environment.